Have you ever looked at a bunch of data and just had a hunch that it could tell you something about the future? Well, today we're going to turn that hunch into a reality. We are going to build our very first prediction machine using one of the most popular toolkits out there, Scikit-Learn. So let's get into it.
It all starts with a question you see answered pretty much every single day. How in the world does your inbox know how to filter out all that junk mail? I promise you, it's not magic. It's actually a prediction machine doing its job, one that's learned the difference between a message you actually want and an ad for something you'd never, ever buy. And the secret sauce behind that spam filter? It's a concept called supervised learning. Think about it. It's like teaching a computer by showing it thousands of examples of emails that you've already marked as spam or not spam. The machine just chews on all those labeled examples, finds the patterns, and then when a new email comes in, it can make a really good guess. It's no different from a little kid learning what a cat is after you show them a few pictures. Now, to build these kinds of machines, you absolutely need the right tools. And for anyone who's getting started with Python, the best all-in-one toolbox you can grab is Scikit-Learn. It is so powerful, it's incredibly user-friendly, and it's exactly what we're going to be using today.
So what's the big deal with Scikit-Learn? Why does everyone love it so much? Well, for one, it plays really nicely with all the other data tools you're probably already using. Plus, its commands are super consistent, so once you learn one algorithm, the others feel really familiar. And, if you ever get stuck, there is a huge community out there ready to help. Basically, it gives you all the power of these advanced algorithms without the usual headache.
The best part about all of this is that building a prediction machine isn't some chaotic, mysterious process. Almost every single project, from the super simple to the crazy complex, follows the exact same blueprint. Think of it as your step-by-step assembly guide. And here it is, the whole blueprint, right here on this slide. It all starts with step 1. You load your materials. That's your labeled data. Then, number 2, you create a test site by splitting that data, holding some of it back to check your work later. Step 3 is where you select your tool, pick your algorithm. 4 is the fun part. You actually teach your machine by training it. Then, number 5, you check your work by seeing how well it does on data it's never seen before. And finally, step 6, you're ready to put it to use and make some real predictions.
Okay, now for the really fun part. Scikit-Learn isn't just one tool. It's a whole workshop full of them. And picking the right one just depends on the job you're trying to do. So let's take a quick walk through the workshop.
All right, our first tool on the tour is Logistic Regression. Now, don't let the name regression fool you. This is a classification tool through and through. The best way to think about it is as a simple, reliable calculator that gives you a probability. Basically, a score from 0 to 1.
So you'll want to grab this tool for what we call binary problems, things with only 2 outcomes. Is this transaction fraud? Yes or no. Is this email spam? Yes or no. It's super fast, it's efficient, and it gives you a nice, clean probability score to go with its decision. Okay, let's level up a little bit. Next up, we have the Support Vector Machine, or SVM for short. Think of this one as a specialist. Its main mission in life is to find the absolute clearest, widest possible dividing line to separate your data into different groups. It's a master of precision. SVMs really start to shine when your data gets complicated, with tons and tons of features. They're also fantastic at avoiding a really common trap called overfitting. That's just when a model learns the training data too well, and then it can't make good predictions on new stuff. And with these clever little tricks called kernels, SVMs can draw a simple straight line or a really complex curvy boundary to get the job done perfectly. All right, now for one that is so easy to understand. K-nearest neighbors, or KNN. I like to call this the social network algorithm. See, to figure out what a new piece of data is, it just looks at the K closest data points around it, its neighbors, and takes a vote. Whichever category wins the vote, that's what the new point becomes. It's as simple as that. KNN is just fantastic when you want a simple approach that's easy to explain. It doesn't make a lot of assumptions about what your data looks like, so it can handle some really weird, irregular patterns that other models might totally miss. It's basically pure democracy by data points. And now, we've come to one of my personal favorites, the decision tree. This algorithm works exactly like a flowchart. You can think of it like a game of 20 questions. It just asks a series of simple yes or no questions about the data to work its way down to a final decision. The biggest win for a decision tree is how transparent it is. You can literally follow the path of questions and see exactly how it made its decision. But here's the thing. While one tree is great, its real power is that it's the basic building block for some even more powerful models, which we're about to get into right now. And that brings us to our next huge idea. What if, instead of relying on just one tool, we used a whole team of them? Well, that's the big idea behind what we call ensemble methods, where we combine a bunch of simple models to create one single superpowered model.
I mean, think about it. A single decision tree, just like a single expert, can be wrong sometimes, right? It might have a blind spot, or maybe it gets too hung up on some weird quirk in the data it was trained on. So how do we guard against that?
Well, we use ensemble learning. It's literally the wisdom of the crowd, but for machine learning. By taking the predictions from lots of different models, sometimes hundreds of decision trees, we can average out all their little mistakes and end up with a final prediction that's way more accurate and way more reliable.
So here's a great way to think about it. A single decision tree, that's one expert making a call. But a random forest, that's a whole committee of experts. Each tree in that forest gets to see a slightly different part of the data, so each one has a unique perspective. Then they all vote on the final answer, and by doing that, we average out their individual biases and get a much stronger result.
And Scikit-Learn has even more advanced ensemble tools. For instance, you've got gradient boosting. That's like building a team of experts one by one, where each new member's job is to fix the mistakes of the person who came before them. It creates this powerful chain of improvement. And then there's extra trees, which takes the random forest idea and just injects even more randomness into the process, which makes the final model incredibly stable.
All right, we have officially toured the workshop. We've looked at the blueprint. So, where do we go from here? It really just comes down to this. You have the 6-step blueprint. You have a powerful and totally free toolkit waiting for you with Scikit-Learn. The only thing left to do is to get your hands dirty, because the absolute best way to really learn this stuff is by doing it.
And as you start building, just keep this one fundamental goal in mind. All this quote is really saying is that your job is to teach the machine to find the hidden connections, the patterns that link your data to the answers you're trying to predict. That's it. That's the magic.
So I'm going to leave you with this final thought. You've got the blueprint. The tools are all laid out for you. The only question left is, what problem do you want to solve? What prediction machine will you build first?